we are solving a sample problem on mass stoichiometry. In mass stoichiometry problems, we are given the mass of one substance and we are to determine the mass of another substance. Here is the problem. What mass of ammonia can be made from 280.3 grams of hydrogen gas and excess nitrogen gas? So here, guys, you will not be given the chemical equation, this formula equation. You should know how to write the balanced equation. So make sure you write the balanced equation first, and you should always write this information at the bottom. So how am I getting this information? So first, after having the balanced equation, you're going to make sure what is given, how much is given, and what do you need to determine. So it says what mass of ammonia can be made. So I have put the question mark here. So this I have to determine, and generally the unit for mass is grams, so that is why I have grams here. Then it says that can be made from 280.3 grams of hydrogen. So here 280.3 grams of hydrogen I have written here. So this is something which is given, meaning this is known, and this one you have to find. So this is your unknown. All right, so this is given and this is you want to determine, you want to determine. So in this problem, we are given the mass of hydrogen 280.3 grams, and we are going to say this is our substance A, and we are to determine how many grams of ammonia NH3 can be produced using these many grams of hydrogen. So this is our substance B. We are going from substance A to substance B. However, going from converting mass of substance A to mass of substance B, it doesn't happen in one step. We have to actually use 3 conversion factors in order to solve mass stoichiometry problems. And here I have 3 equivalents for you. Already I have written them for you guys to use them, and from each equivalent we can make 2 conversion factors from each one. And which conversion factor we use is the one where you have the starting unit at the bottom and the unit that you want to end up at the top. Alright, so let's start with the given. We are going to start with what is the given mass here? 280.3 grams of hydrogen. Okay, over 1. Now we are going to convert this given mass of hydrogen. So what is this? This is the mass of A, substance A, this one. We are going to convert this into moles of substance A. Now in order to do that, we need to use the molar mass here. 1 mole of hydrogen has the molar mass of 2.02 grams. Now where are we getting this number? We are getting this molar mass from periodic table. Well, on periodic table you see the molar mass only for elements, and then depending on what's the formula you solve it. So here, because it is 2, you are going to multiply the mass of hydrogen by 2, and that is how you get this 2.02. Okay. Now so when you make the 2 fractions, you are going to pick the fraction where you can get rid of the units you don't want and keep the units that you want. So there is a possibility, one of the possibility is the fraction you can make from here is 2.02. There are 2.02 grams of hydrogen, which is the molar mass in 1 mole for every 1 mole of hydrogen. So I want my moles, so I'm going to write at the top, and I want to get rid of the grams, so grams I'm going to write at the bottom. So cancel this unit and this unit. Here you go. So this one is the molar mass. Well, but this is inverse. Why are we saying this is inverse? Because you have grams in the denominator and moles in the numerator. Now again, we have to convert these moles of A, which is moles of mass of substance A, to moles of substance A. Now we are going to convert these moles of substance A to moles of substance B. How are we going to do that? That we are going to do by comparing the moles of substance A and B. So let's look at our balanced equation. For every 3 moles of hydrogen used, 2 moles of ammonia are produced, right? So we want to get rid of moles of hydrogen. I'm going to write this one at the bottom. And here again, this is so this one is the molar mass fraction. This equivalent, you make molar mass fraction from here. From here, you make mole ratio conversion factor, and from here this one you again make molar mass conversion factor. So 1, 2 and 3 conversion factors. So now since we are converting moles of A to moles of B, we are using the mole ratio. So for 3 moles of hydrogen used or consumed, 3 moles of hydrogen consumed, 2 moles of ammonia gas are produced. So here you go, get rid of moles of hydrogen, moles of hydrogen. Okay, now we are not going to stop here because this is giving us only the moles of ammonia. However, we have to find the mass of ammonia. So in order to convert from moles to mass, so from moles to mass, now we are going to moles to mass. So mass of substance A to moles of substance A to moles of substance B to mass of substance B. We are again going to use the molar mass. All right. So here 1 mole of NH3 is how many grams? 17.03. Again, we have used periodic table to determine the molar mass. I want to get rid of the unit moles of ammonia. So I'm going to keep this one in the denominator. Okay. So once again, from each equivalent, you can make 2 fractions. All right. So guys, these equivalents will not be given to you. This is a unit analysis method. You should know these equivalents. You should know how to write the equation. All these things you should know. All right, cancel this same units. Now you are left with the grams of ammonia, which is the mass of ammonia substance B. So let's revise again. What did we do? We converted, we went from mass to moles to moles to mass. Alright guys, now use your calculator, and when you plug in the values, you're going to get this number. And don't forget to write the units. Units is very important, and also the substance. What's the substance we are talking about? Here, these many grams of ammonia are produced when 280.3 grams of hydrogen is consumed in the reaction with nitrogen and hydrogen. Alright, now one more thing. Let's see, we have significant figures as well. 1, 2, 3, 4. 1, 2, 3, 4. So only 4 significant figures. Grams of ammonia. Now if you want to be fancy, you can put your answer in scientific notation. Otherwise, I'm fine. You can leave it like this. Right? So here are the 3 steps to solve mass stoichiometry problem. Whatever I was saying is written here. So read everything carefully. And thank you for watching, guys. I hope the video was helpful.